Nobody ever calls me doctor anymore. That was really cool. Thanks for the introduction, Alex. Thanks to all the conference organizers. I'll echo the same sentiments that everyone else has said today. It's so cool to be here. Seeing people in the flesh finally after 2 years of meeting people digitally. It's just been so great. So we're so happy to be here. So I'm Matt. I'm a co-founder and CEO of Future Fields, and we make most sustainable and cost-effective growth factors for the cultured meat industry. So today, I want to talk to you guys about life and food, and more importantly, why we need to think about creating our next food system with cultured meat more sustainably. So why do we care about sustainability? Why do we care about the state of the world in 100 years when no one in this room is going to be around to see it? Because someone else will be, right? Our kids, future generations of humans, future generations of animals, and every other living species will be. We work for a more sustainable future for them. My daughter's 2 years old now. We started our company right around the time she was born. And I'm sure all the other parents, aunties and uncles, grandmas and grandpas, caregivers in the crowd watching online feel that same sense of urgency that I do. We align our work with the needs of a planet in peril for them. That's what's at stake, life. And life is everywhere. Let's take a minute, let's stroll down memory lane to our first biology class where you would have learned about the circle of life. As kids, we learned animals consume plants and other animals. They die, their bodies decompose, return the nutrients into the soils, which feeds the next generation of plants, animals, insects, which in turn feeds us. And as humans, we used to be really good at maintaining this, or at least not disrupting it too much. Some of the oldest farming methods dating back to the dawn of agriculture, use these no-tillage methods, which maintained the integrity of the soil. And that is the foundation for all this. The foundation is the soil. It's the basis of the ecosystem. It's the very bedrock of the food chain. For meat production and crop production alike, so long as we're doing anything with plants or animals, healthy soils are required. Think for a second, have you ever dug your hands into really healthy, rich soil? Think about what it feels like, what it smells like, what it looks like. It's dense with organic matter. It's teeming with life. Insects, bacteria, fungi, all performing services in the soil's ecosystem. And keeping this ecosystem is absolutely essential for food production. 95% of the global food production is directly or indirectly linked to our soils. And to root this in cell ag and cultured meat production, this means things like crops for hydrolysates, sugar for the glucose and basal media. So even cultured meat and cell ag requires healthy soils. And of course, so does food production. By 2050, we need to increase global agriculture production by 60% just to meet the demand for food. And a lack of any one of the 15 nutrients that are required for plant growth would significantly limit crop yield. The need to protect what we love and our way of life has driven the need to scale. We've had to maximize yields to feed 8 billion mouths and the countless number of animals that are involved in industrialized agriculture. And this need for maximum yields has had some pretty severe side effects. It's disrupted the natural cycles of our soils. We've resorted to methods of industrialized monoculture, which has fed so many efficiently and cheaply, but again, has ruined biodiversity and it's, ripped life out of our soils. We now have to mine nutrients from the earth and jam them back into the soil just to keep the machine going. It's a very unfortunate reality of our scaled food production system. A United Nations study from 2017 estimated that 1/3 of the planet's soils are degraded because of modern agricultural methods, and monoculture tops the list of those things to blame. Other processes are similarly problematic. Mechanical tillage of crops kills countless forest animals. Pesticide and insecticide use is certainly problematic. A study showed that 16 quadrillion honeybees were killed by insecticide use in the UK alone over 20 years. 16 quadrillion. I've never even said that number before. This is humanity's MVP in crop pollination. Anyways, my point is, when we think about the problems of our food system, we need to take a more holistic view. It's not just animal agriculture that's the problem. It's the entire system. So I truly believe that cellular agriculture and cultured meat production has the potential to fix all this. Now, I wouldn't be up here if I didn't believe that. Alongside sustainable practices of agriculture and plant-based alternatives, this is our best shot, at fixing all this. I imagine most of the people here know why that is. I'm preaching to the choir. I don't need to, list all the benefits of producing food this way. And a lot of people smarter than I am have said it more eloquently than I could. I really like this quote from Churchill because, even he knew 100 years ago the absurdity of making food the way that we do. And, we haven't quite escaped that absurdity yet. But every day we get a little bit closer because of the work that's being done by the great people in this room and the people watching online. So far, there's been a lot of optimism about our ability to pull this all off. And a lot of the initial analyses that have been done, while describing the challenges that we face as an industry, have showed, an optimistic view of how we can do this. The Delft TEA, for example, did a fantastic job of showing the different scenarios that would lead to price parity for cultured meat. Certainly illustrated the challenges, but there was an optimism to it, and it demonstrated that it can be done. And scientists are certainly a skeptical bunch, but the fact that we have so much optimism about this demonstrates this. And then came this article, published in the Counter last month. This dealt a pretty significant blow to our optimism. It described cultured meat production as a Sisyphean task. It said that it would never be commercially viable. And it really rocked the community. There was so much buzz about it. So many industry champions were quick to respond. But it wasn't the first article that shared these sentiments, so why did this one hurt so bad? And I think it hurt because there was an element of truth to it, and we all knew that. Turns out, growing meat outside the animal is really hard, and scaling it is even harder. That's kind of the basis for the author's argument. It will never be commercially viable at scale. But where it stung the most is it kind of showed what we all knew was there, an almost incomprehensible need for infrastructure. And this was really highlighted in this quote from the underlying TEA. We gaze into the abyss of 10 orders of magnitude. 10 orders of magnitude. It's a very hefty challenge. We know we're not currently equipped for this level of production. The media requirements alone are unprecedented. Even the more optimistic Delft TEA illustrated how 40,000 liters of growth media would be required to produce just 3 tons of cultured meat. So based on that, if we wanted to satisfy 10% of the US meat market, we would need 16 billion liters of growth media. So we're a growth factor recombinant protein company, so focusing in on just those components, and let's say we look at just one. Let's say insulin. It's kind of required for all growth media. There's a lot of infrastructure for it because it's used to treat diabetes. So insulin's typically used in growth media around 20 milligrams a liter. So 20 milligrams a liter, 16 billion liters, equates to 320 metric tons of insulin. That exceeds the global capacity for insulin production at the moment. So even if we dedicated every therapeutic insulin manufacturer in the world to insulin for cultured meat production, we couldn't even satisfy 10% of the US meat market. Humbard's analysis in the TEA kind of leans on this hypothetical 10-ton manufacturing facility for monoclonal antibodies. And while he recognizes that this is hypothetical, it really highlights the massive demand for infrastructure. This scale exceeds really any type of production we know. Scalability is not just a burden for cultured meat producers to bear. The entire supply chain has to scale, and it has to do so sustainably. 320 metric tons of insulin. That's one target for 10% of one market. Existing systems are just not built for this. It's not feasible in any sort of reasonable amount of time. And time is something, unfortunately, we're running short on. Adding salt to the wounds, the climate clock is ticking. The latest IPCC report really highlights the urgency of this. We don't have decades to figure this out. We need as many irons in the fire as possible. The situation is so bad, we're looking at employing strategies like geoengineering. And of course, Elon's heads down on our Mars escape plan. This truly is code red. But there is hope. Again, I wouldn't be up here if I didn't believe in this. Yes, cultured meat is not inevitable, like some have said. Yes, it is going to be very hard. But just like the GFI responded, it's way too early to write it off. We cannot afford to not invest significant time, energy, and resources into its development. We need some serious innovations, and we need to significantly bolster our infrastructure. Basically, we need to science the shit out of this. That's where we come in. That's where Future Fields comes in. We see this infrastructure gap on the B2B side, and we're working tirelessly to fill it with a new innovative expression platform. We need unprecedented scale, and we need it at extremely low cost. And that's why we built the Ento engine, a first-of-its-kind insect-based expression system to produce recombinant proteins for this industry. We're utilizing one of the best-studied organisms on the planet, Drosophila melanogaster, to produce high-functioning growth factors for this industry that meet the needs of this industry. When it comes to the challenge of scaling costs, we don't have that significant upfront CapEx like other systems. We don't have the mountain of costs that come with some hypothetical 10-ton facility. Our infrastructure is inexpensive, and our mini Drosophila mansions are completely modular, rapidly scalable. And with that, we're building a very cost-efficient and scalable system. And we're having fun doing it. This is what our transferrin, or what Myoblasts have to say about our transferrin. And there's a number of other advantages we have. There's a very clear regulatory path for our types of products, given the precedence of insects and insect-derived byproducts already being used in food. And we know how important the regulatory is for the inputs as well. That's certainly been highlighted today. We're spending a lot of time and energy on this. We just had a meeting with the FDA actually this week about pursuing GRAS status for our growth factors. But most importantly, we have the potential to produce extremely sustainable inputs, with basically zero waste output and completely upcycled inputs. We built this platform with all of these things in mind: cost, scale, food safety, and sustainability. And when I said we can scale fast, I really mean it. This is what we've accomplished so far. So we launched our first product, FGF2, back in February. At the time, we were producing literally just enough for our own in-house testing. And we started sending out samples to many of you here in the crowd and realized we really needed to boost our production. So we hired a fantastic team of engineers who built, those Drosophila mansions I mentioned, this completely modular scale-out system that allowed us to hit 10,000 liters of supplementation capacity by July. And we're continuing to build this up well into the future. This is where we'll be going over the next 10 months or so. So this is specifically for FGF2, but you can assume a similar trajectory with all of our products. And we have a lot of certainty around this, again, because of this scale-out strategy. We don't run into the unforeseen challenges of scaling up. It's completely modular. So we can say with a fair bit of certainty, this is what our production capacity looks like over the next 5 years. So we anticipate, being able to hit around 2.5 million liters of supplementation capacity per month by 2026. And we can trace that directly to the footprint that's required, because again, it's completely modular. So to hit that number, to hit 2.5 million liters per month, it would actually only require about 2,000 square feet of dedicated facility. And if you're really interested in what that looks like and how we do this, you can come find us after. We can show you some cool pictures. So one of the big challenges with scaling is consistency. How do you build a system that scales well but produces consistent products? We know it's obviously very important as a manufacturer to be using consistent products from one batch to another. So shown here is performance of our FGF from 3 different batches compared to competitors. So these are C2, C12 cells cultured in growth media with our FGF2 versus a competitor. And this is showing the number of population doublings observed over a 24-hour period. So as you can see, not only do we see a faster rate of proliferation, but we also see very consistent performance from one batch to another. And this is something we've seen in our partners' hands with their cell lines as well. So now let's talk about everybody's favorite topic, which is cost. Scaling really only matters if we can do it cost effectively, right? We need to get down to price parity. We can only do that with inexpensive inputs. So these are our price projections over the next 5 years as well. And to be specific, these are prices, not our cost of production. So right now, we offer FGF2 for about $150 a milligram. You can find that price on our website right now. You just add it to a cart, check out. It's like Amazon for growth factors. So as we continue to scale, the benefits that we'll see from the economy of scale will drive down our production costs, obviously, showing a trajectory that looks something like this. Ultimately, we know with inputs like FGF2, they need to be below, well below $1 a milligram at scale. Other products like, transferrin and albumin need to be much lower. These are, need to be unprecedented costs. So we also have transferrin available, which, as you've seen, Myoblast Find Delicious. Albumin is something we're working on as well, prolactin, insulin, and a number of other bespoke products that we're working on with our partners. And if you're interested, you can see a complete product roadmap on our website. So again, we turn to the services of the ecosystem, and we steward the rearing of our insects and pay homage to the role that insects play in all food systems. Regenerative agriculture, crop pollinators, even the crops that would produce competing products. Insects are there. And this whole climate thing, if we don't get it right, insects will be there long after we are. And with actually incredible timing, the first PhD in cellular agriculture was recently granted. And yes, that incredible work used insects. As we look to new systems like cultured meat and cellular agriculture, we need to widen our view of the problems with our food system, or we're doomed to repeat the problems of the past. In the beginning of our story, animals' life and healthy soils beget the requirements for food. A balanced ecosystem operating in harmony until we came and scaled life out of the equation. And now we sit staring across a chasm of challenges. With the looming climate threat, we don't have the luxury of hoping for a miracle home run. We need to be focused on base hits. We need to focus on real, tangible steps in the right direction towards a more sustainable future of food production. As an industry, we do face a mountain of challenges, but Future Fields is very proud to be a part of this as we play some small part in the next agricultural revolution alongside all of you. So thanks everyone for your attention, really appreciate it. Again, thanks to the conference organizers. This has been fantastic. Chris and I are here for a few days. My understanding is Chris owes a few of you some beers, so please be sure to collect tonight. Yeah, thanks again for your attention. Happy to take any questions.
Thank you very much. And if anybody has any questions, feel free to line up here.
Hi, I'm Jess Krieger. Great presentation.
Thanks, Jess.
I have a question about the expression systems for the recombinant proteins. Microbial systems aren't well equipped to do proper protein folding and post-translational modifications of proteins. What about Drosophila?
Yeah, so what we know is that pretty much all of the post-translational modifications and different types of protein folding are really well conserved in insect cells. That's part of the reason we chose it as well, is needing to produce high-functioning proteins. There's this misconception that growth factors work or they don't. It's not binary, right? There's a scale, there's a spectrum of function. And so having growth factors that function really well is really important, right? You need to induce cell proliferation really well. So from what we've seen, and we think that's part of our hypotheses of why we get better proliferation out of our products, is because the protein itself, it's better folded, possibly more stable, has the proper epitope decorations, post-translational modifications on the protein that are essential for protein function.
And do you think that's the case for your entire projected product portfolio?
Well, I can't say until we're doing it, but so far so good. FGF2 is a pretty simple protein. That's not a huge challenge, obviously, but transferrin, is glycosylated. It has some disulfide bonds in there, so definitely a more challenging protein, and we've seen really good performance with it as well. So can't say for certain, but we're pretty confident that we'll be able to produce most, if not all, proteins. The nice thing too is that if we do run into situations where there is some PTM that's not conserved in Drosophila for some reason, there's ways to put the enzyme into the background of that line as well, so that it can facilitate that modification.
Great, thank you.
Thanks, Jess.
Hi, thanks, Matt, for such a wonderful talk. I'm Bree from New Harvest, and I loved your focus on the ecosystem and the soil and ecosystem services. I do think that's something the field oftentimes doesn't talk enough about. So do you think that those benefits of trying to go back to ecosystem services and preserve our soils is a guarantee in this field? Or do you think there's something that we should be doing as an industry to ensure that those impacts are achieved?
Yeah, I mean, that's exactly it. I think that's kind of the point here is, we can't just rely on, systems that aren't going to fix the whole side of food production, right? It's not just about animal agriculture. So we need to be cognizant of employing methods and using sustainable inputs, right? It doesn't matter if we achieve commercialization of cultured meat if the inputs, the supply chain drags back in all that nasty environmental baggage. So absolutely, that's really important for this industry to consider, and considering it right now as we're developing it.